Oh, we were discussing matrices last week. So you did last exercise that dealt with vectors, and specifically the um, vector multiplication and power and all those. Basically, you dealt with the array manipulation of vectors, or array arithmetic of vectors, in which you're not performing matrix multiplication, but you are performing array-wise operation. That is, you are performing operation between the corresponding elements of two vectors, or each element of the same vector. You're taking power, or you're dividing that by a certain number, or stuff like that. And for that, we discussed that you have to put a period before every multiplication sign when you're multiplying two vectors that has same length, and you have to put a period before the division sign. Again, if you're dividing a vector by another vector and both vectors should have the same length, or if you're dividing a vector by a constant, you still have to put a period before the division sign. And if you're taking power of each element of a vector, then again, you have to put a period before the power sign, before the caret sign. That's the array-wise operation between the two vectors or on a vector itself. If you don't do that, if you just put multiplication sign, then it will assume that you are multiplying two vectors with matrix multiplication operation. And again, it will produce an error because the dimension of the first matrix, the columns of the first matrix or first vector may not be equal to the columns of the rows of the second vector. So it will, or it may give you an error. As far as matrices are concerned, we discussed matrices last week, as well as how you define matrices, how you replace a row of a matrix or a column of a matrix, how you can delete a row, how you can delete a column, how you can access a specific component of a matrix. So all of those things, those items we discussed last week. Today we are going to start with something that you also did in LabVIEW, which was the simultaneous equation solution. So if you have an equation written, for example, if you have, I'm just going to put a comment. So if you have 3x plus 5y plus 7z equals 23. Let's say this is the first equation, 3. And then you have 8x plus 8y plus 12z equals 65. And I'm putting percent sign so that you have, it's not going to give an error. Otherwise, it's going to give an error. It's going to ask to enter the values of x, y, and z. And of course, you cannot write the equations 8x. It has to be 8 times x. So these are just comments I'm putting. Let's say you have 3x plus 2y plus 7z equals, let's say 17. So let's assume you have a set of simultaneous equations defined by these three equations, as you can see, and you want to find out the values of x, y, and z. Again, using matrix inversion method that we discussed in LabVIEW. How you are going to do that in MATLAB. There are multiple ways to do this in MATLAB, but we're going to use, again, matrix inversion method that we discussed in LabVIEW. Now, if you remember the matrix inversion method that we discussed in LabVIEW, my tablet. Remember, if you're writing this in terms of matrices, then we can write this thing as 3, 5, and 7, 8, 8, and 12, and 3, 2, and 7. X, y, and z equals 23, 65, and 70. So we can write these three equations in terms of matrices using the three matrices. This matrix defines the coefficients of x, y, and z. This is called the coefficient matrix. This matrix defines the variables, the unknown variables. which is a vector in this case. And this matrix, again, this is a column vector. It defines the constant on the right-hand side of the equation. So this is, if you remember, we discussed that in LabVIEW, that this is how you can write simultaneous equations in terms of matrices. Now, this is matrix multiplication between the matrix A and matrix X or vector X. This is matrix multiplication. You have 3 columns of A and you have 3 rows of X. So you're doing the matrix multiplication. And when you do the matrix multiplication, it's going to be 3x plus 5y plus 7z equals 23 on the right side, 8x plus 8y plus 12z equals 65, and 3x plus 2y plus 7z equals 17. So this is how you write simultaneous equations in terms of matrices. And when you have to find the unknown coefficients, the unknown variables, then you take A on the other side of the equation, and it becomes the inverse of A. And then you multiply it by the vector C. And again, this is a matrix multiplication. So this is something that you did in LabVIEW as well. If you have to do in MATLAB, the same thing, how you're going to do that. Let me go ahead and delete my drawing, otherwise it's going to be in the way. So let's go ahead and delete this. Okay, let's close this. So to perform, to calculate the values of x, y, and z, the unknown variables, using matrix inversion method, first you define, of course, your matrix A. And matrix A is comprised of the coefficients of x, y, and z. So 3, 5, and 7, the first row, 8, 8, and 12, second row, and 3, 2, and 7, the third row. And the coefficient C is 23, 65, and 17. It's a column vector, of course. Oops. And remember, if I also mentioned that if you don't want to create a column vector by putting semicolon between each row, you can just create a row vector and then take the transpose of that. That is, put a apostrophe sign, and then it will take the transpose. It will convert rows into vector, rows into columns, column into rows. So we have A and we have C. If you want to find out what is the unknown vector X, then simply X is equal to A to the power -1, which represent A inverse, times C. Now observe, I'm not putting any period because it's not area multiplication. It is a matrix multiplication. And that's going to produce the value of x, y, and z. 9.35 is x, 2 is y, and -2.15 is z. That's one way to do, one way to calculate the unknown variables from linear equations in MATLAB. You have 2 more ways to do that. There's a function, let's say x1. There's a function which is called inverse, INV. You can take inverse of any matrix, any square matrix that has again the characteristics of square matrix that you can take inverse. Some of them you cannot take inverse, but let's assume that you can take inverse. Then INV will produce the inverse of the matrix times C. Again, matrix multiplication, and it's going to produce, of course, the same result as you can see. The third method, which is the quickest method, is just use the backslash between the coefficient matrix and the column vector. And that will also produce inverse of the matrix times C. That is going to produce the same result. So you have 3 different ways in which you can calculate the unknown variables from linear equations in MATLAB. Either you take a to the power -1, A inverse times C, or INV function, or simply my favorite is, this is the quickest one in MATLAB, takes the least amount of time, is A backslash C. And each of them is going to do the same thing and produce It's going to produce, it's going to perform the inverse function of A first, and then it's going to multiply it by C. That is one of the topics in the tutorial. One of the exercises that is given is the same exercise that you have to find the values of the unknown coefficient, but that exercise is not part of your homework. So I'm not going to go over that exercise, but it's right here, this exercise 5. So that's not required for the homework, although one of the exercises that is part of the homework is based on basically your the same concept, inversion, the solution of linear equation using inversion method. So exercise 5 is not part of the, actually exercise 5 and 6 both are not part of your next week's homework, 7, 8, 9, 10, 11, 12. Let's look at how do you ask user to give an input? Because so far we are providing values of different variables ourselves to evaluate equations and all those things. But what if you want to ask user to enter values? How are you going to do that? I'm going to go ahead and work in my editor for that. So let's say this is an example to get input from a user in MATLAB or Octave. Let's assume you're solving an equation and you want the user to give you the values of the variables to solve that equation. So how are you going to ask user? And let's assume, let's write down what equation you're solving. Let's say you're solving the same equation that we had. Let's say, so let's assume you're solving 3x plus 5y plus 7c. So let's write that down, or any equation actually. Ask the user to enter values for x, y, and z to evaluate fx, y, x comma y comma z equals, I'm going to write an expression, 3 cosine 5xy plus 8 sine 2yz divided by xy plus z over x. Let's say you have this equation and you want to evaluate this equation for different values of x, y, and z. And first, I'm going to show you if there's a scalar values. That is only one value for x, y, and z. Of course, you can evaluate it for vectors, matrices, whatever. But let's just start with only scalars, and then we can extend this to vectors or matrices as well. So you're going to ask user the same thing. Now, to ask user, there are two ways to do that. First way is to ask the user separately enter the value of x, enter the value of y, and enter the value of z. And the second way is ask the user to enter all three values at the same time as a vector, and then you separate each value in your program. So let's do both of them. So start with the easier one. That is, x is equal to, now to ask user to enter anything, the function in MATLAB is input. Input, and then anything that you want to ask, it has to be very clear as what you're asking user to enter and how the user should enter that thing. So let's say I ask the user, enter the value of the variable x to evaluate fx comma y comma z, and I can put the whole equation, but I'm just going to put down fx comma y comma z, and that has to be written in quotes because that's a message that you want to convey to the user. So enter the value of the variable x to evaluate fxyz. And then I'm going to put a colon over here and put a space because when user is going to enter it, I want the message and the value to have at least one space between them. Otherwise, it's going to look like that the value is part of the message if you don't put any space after, after the message, basically. And this message has to be in quotes because this is a string. It will be printed as it is. So to get the input, you're going to use the input command. And in parentheses, you're going to put a message as what you want the user to enter and how the user should enter it. So I did not put down what is x. Is it a scalar value? It's a vector value? It's a matrix value. It's important that you mention it as well. Enter the value of the variable x. A scalar value, let's say if I write down. A scalar value means that a single value, not a vector, not a matrix, to evaluate fxyz. So now the message is very clear that you want the user to enter a value that is going to go in the variable x, that is going to be used for the variable x to evaluate the equation, which is, the whole equation. I can write down the whole equation here, but not writing right now. And that value is a scalar value. It's not a vector. That variable is not a vector. That variable is not a matrix. And then I'm going to put a semicolon because I do not want that value to be printed again since the user is already going to be entering that value. So we don't want to reprint it. So put a semicolon after that. I'm going to do the same to ask for the value of y. And I'm going to change this to y. And then I'm going to same to ask for the value of z. So this is how I'm going to ask the user to enter each one of them separately. Now, as I said, you don't really have to ask each of them separately, and we're going to discuss that as well. Let's go ahead and save this thing. Save MATLAB. Once the user is going to enter each value, they will be assigned in the variable x, y, and z that you're using to hold those values. And now all you have to do is to write the equation. So f is equal to 3 times cosine of 5 times x times y plus 8 times sine of 2 times y times z divided by xy divided by x times y and plus z divided by x. Since these are scalar values, single values, so I'm not really going to use any period anywhere in order to evaluate the expression. And that's pretty much it. You don't have to put any colon, semicolon. If you want to print this value, if you don't want to show this value, you put semicolon. But since our goal is to evaluate this value, we definitely want to show this value. So we are not printing it now. If it's a huge program, you're doing something, and this is just a step somewhere to evaluate the value, but you don't necessarily have to show the value, then definitely you're going to put semicolon after this line in order to evaluate it and use it in the following steps, but not necessarily you want to show this value. Right now, my goal is to evaluate this expression, and of course, I want to know what the result is. So I'm not going to put any semicolon right now in front of this statement. So let's go ahead and run this thing. Oops, parser. What's the parser? Let's see. Sometime, but that was earlier. Okay, here you go. So it's asking me to enter the value of the variable x, which is a scalar value, to evaluate that. Let's say I enter 3, and then it's going to ask me to enter the value of y, let's say 4, and then let's say 7 is z. So it's going to evaluate that expression, and the result is going to be negative 0.8716. 1.2, 4.5, and 6.7. 3.8585. So this is your input function. If you want to input any variable, whether that variable is a scalar, vector, or matrix, the value, this is how you're going to use it. The variable can be, as I said, can be vector, can be scalar, can be matrix. Right now, we are only asking the user to enter a scalar value because this equation can only evaluate the scalar values. Let's say if you give permission to the user to enter XYZ in whichever format, either all of them should be scalar, all of them should be vectors of the same length, all of them should be matrices the same length. Then how you are going to, first of all, give that message to the user, because you have to again tell user what to enter and how to enter it. So if I want my XYZ to have either format, scalar, vector, or matrix, and I want to make sure that each one of them have the same length, because if I'm performing array-wise operation, they must be of same length and same dimension. Then you have to give a message, appropriate message first, and then user is going to enter X, Y, and Z. So let's say enter the value of the variable X. Let's say scalar, vector, or a matrix to evaluate fxyz. A scalar, a vector, or a matrix. Likewise, y, I'm going to do the same thing. A scalar, a vector, or a matrix of the same dimension as X. So you have to be very clear that you cannot just enter any vector or any matrix. The dimension of the vector or a matrix has to be the same as what you entered for X. Otherwise, it's not going to work. And you do the same thing for this. Okay, so now you're giving permission to the user such that user can enter X, Y, and Z of any data format, scalar, vector, or a matrix. Which means what? Which means you will have to make some modifications when you're writing this equation F. So who is going to tell me what modifications should I make in order to evaluate any type of input that is coming in? Of course, input has to be same dimension, X, Y, and Z, but they can be vector, matrices, or simply scalar values. But what modifications should I make in this equation in order to accommodate any type of input data? Who is going to tell me?
You're talking about the dot before?
Periods, yes.
Yeah, the periods, yeah. Sorry, the periods. Because you say or matrix, so.
Yeah, vector or matrix. Of course, if you're doing vector or matrices and you're performing array-wise operation, you will have to put periods before multiplication, division, and power sign. So where exactly I'm going to put periods in this equation in order to accommodate any type of input data? It will work for a scalar as well.
You'd put the period like before the, I think any multiplication or division.
Okay, tell me in this equation exactly where I'm going to put it.
Before the z divided by x.
Okay, so let's go ahead and z divided by x. Where else?
The x times y in the parentheses.
Okay, where else?
The y times z, and before the division right here.
All right, where else?
The 2 times y.
No, to delta, you don't have to. You can.
Oh,
But remember, if you're multiplying a constant by a vector or matrix, you don't have to put period. If you do that, it's not going to give an error, but it's redundant. You don't want to put it over there. It's just redundant.
okay.
If you're dividing a vector or a matrix by a constant number such that you want to divide each entity of that vector or matrix by that number, then you have to put period.
Okay.
But yeah, you don't really want to put period here. Again, if you put it, it's okay. It's not going to give any error, but it's not a good practice. So let's not put it over there. Whereas there's one more place.
Be x times y.
X times y, exactly. So these are all the periods you're going to put in this equation in order for this equation to accommodate any type of input data, whether it's a scalar data, vector data of the same length, or matrix data of the same length. Let's go ahead and run this thing. Here you go. All right, enter the value of the variable x, a scalar, a vector, or a matrix to evaluate x1. So we already did scalar. Let's start with the vector. Let's say 1, 8, and 9. 1 row, 3 columns. Variable y, scalar vector matrix of the same dimension as x value to evaluate that. So let's go ahead and y, choose 8, 1, and 3. Again, same dimensions. And do the same thing for z, 12, 5, and 8, same dimension. So it's going to evaluate f. And of course, f is going to be same dimension as x, y, and z that you can see on the screen. If you are having people talking in the background, can you mute yourself and just unmute if you want to ask a question? So again, input function, you can ask user to enter any type of data, scalar data, matrix data, or vector data. Everything is okay. Just have to be careful to convey the message clearly to the user as what should be entered and how should it be entered. And when you're writing the equations, then of course you have to write the equation very clearly. All right, if you want to input a text, a string, then how do you do that? To input a text or a string, let's say name. You want to ask user, what's the name? What's your name? Or anything like if you're doing something using different methods, you want to ask the name of the method. So whatever you want to enter, but as long as it is a string or a text, how are you going to ask user to do that? So again, input function is the standard function to get any input from the user. And there are two ways to get the input of characters or a string. One way is, let's say, enter your name in quotes. So one way is that you want to ask user to enter some data or some string, and you have to instruct the user as how the user is going to enter that. That is, the user has to enter in quotes as a string. That's one way to do that. Let's call this let's call it name. And let's go ahead and run this. And I'm gonna come back to this when we print these things. Let's go ahead and run this. So let's say 1, 3, and 4, and then enter your name in quotes. So let's say Masood. So if I look at what is the variable name, it holds my name as characters. So that's one way to ask the user to enter a string of characters. Now these are strings, they are not numbers. Anything that will be entered in quotes, that will be treated as characters, whether you're entering number, letters, special characters, anything that you're entering in quotes, that will be treated as characters. So you cannot treat them, even if you're entering the numbers, you cannot treat those numbers, you cannot use those numbers for multiplication, division, or any mathematical operation because they are treated as characters. The other way, easier way perhaps, to ask the user to enter characters is without quotes. But what you have to do, you have to write that this input, treat it as a string. So you have to put in quotes S after the message that you are giving to the user to enter. So you put quotes in quotes S to treat this input as a string. And this is a better way to ask the user for entering any character. So that user doesn't have to put in quotes and stuff, just write down anything, and that will be treated as a string. So if I run this again. Enter your names. Now I don't have to put any quotes, and I put my name, and I should have put actually colon here at least for good practice. And again, if you call what is saved in name, it's still my name that is saved in there, but I don't have to put my name in quotes. So this is a better practice if you want to ask the user to enter some sort of a string, is to put S and instruct the variable that this variable is a string variable, instead of asking user to make it a string and assign it to the variable by entering whatever the user is entering in quotes. So these are different methods to enter numbers. Numbers can be scalars, vectors, matrices, and enter just characters, basically. Another thing that I wanted to show you was, if instead of writing X, Y, and Z separately, if you want to ask the user to enter all of them at the same time, especially for the scalar values of X, Y, and Z, then how are you going to do that? Let me go ahead and delete this over here. And let me go back and then write down variable X, a scalar value. I modify this variables X, Y, and Z scalar values. And I'm going to call this, let's say, I don't know, let's call this XYZ. So I want the user to enter everything. So enter the values of variables X, Y, and Z, scalar values. And I'm going to make it a little clear as how user has to enter as a vector. The user has to enter it as a vector. Those are scalar values, that is a single values, but user is going to enter the 3 values as a vector. That's what I want the user to enter. So the user is going to enter, I'm going to save that vector in X, Y, and Z. Now, X is my first value of the vector, Y is my second value of the vector, and Z is my third value of the vector. So what I'm going to do in my program, I'm going to define X is equal to what? X, Y, Z, 1. So that's my first value of X, Y, Z. I'm going to assign that to the variable X. My Y is equal to X, Y, Z of 2. My second value of X, Y, Z vector, I'm going to assign it to variable Y. And my Z is equal to X, Y, Z of 3. So now I'm not asking user to enter all 3 values separately. And in my program, I'm assigning each value to still X, Y, and Z values in order to use them in the equation, which is defined with the variables X, Y, and Z. And if you don't want X, Y, and Z defined in the equation, you can just write down wherever X is used, you can just write down X, Y, Z of 1 For y, use xyz of 2, and for z, wherever z is used in the equation, you can use xyz of 3 in the equation. So use different variables instead of xyz. I think the equation is easy to write with x, y, and z, and it's easy to just assign those xyz values outside the equation as the first value of xyz variable to be x, second value to be y, and third value to be z. And I'm going to take this here because I'm going to use that for the next part that we're going to do. Okay, so now if I run this thing, then it's going to ask enter the values, enter the value of variables, or enter values of variables x, y, and z, scalar values as a vector to evaluate x, y, and z. So I'm going to enter now as a vector 12, 18, and 21. 12 being x, 18 being y, and 21 is z. Enter your name. And since I put a semicolon after this, then it did not show me the result right here. So let me remove this. But the result is calculated, of course. If I look at f, then the result is 4.0626. 1, 2, 3, 8. The result is negative 1.66354. X is 1, y is 2, and z is 3. So it's preferable if you are entering multiple values to be used in an equation, or it is preferable to use those values as long as they're scalars, scalar values, to use them as a vector. Now, if the values are not scalar, they are vectors, then you can ask the user to enter each vector as a row of a matrix, and you can create a matrix. And then later on, you can divide that as, we are over here, we are saying x is equal to the first element of xyz. But if xyz is a matrix, each row of the matrix defines x. The first row defines x, second row defines y, third row defines z, let's say. Then instead of saying x is equal to xyz1, who's going to tell me how I'm going to extract the first row from a matrix? If xyz is a matrix with the first row, the values of x, how I'm going to extract that, the first row? Who's going to tell me that? We discussed it last week. How you can extract a row or a column from a matrix. Nobody remember that? If you want to extract the first row or the second row or the third row, all you have to put is comma, colon. That is first row, all the columns. Second row, all the columns. And third row, all the columns. So if you want the user to enter x values, y values, and z values, and all those variables are vectors. Each variable has multiple values, vectors of the same length, of course. Then the user can enter that as a matrix with first row variable x, second row variable y, third row variable z, and this is how you're going to extract each one of them. First row, all columns, 1 comma colon, second row all column, and third row all columns. And if they are divided among columns instead of rows, the first column is x, second column is y, and third column is z, then how are you going to extract that? Who's going to tell me? How are you going to extract if the first column is x, second column is y, and third column is z? Anyone? No, it's the same thing.
Is it a comma?
I'm sorry?
Do we put a comma in the thing, or is it a semicolon?
I'm not talking about semicolon. I'm talking about what will be how you're going to present the indices to extract the first column. If the first column is X instead of first row.
Is it just a semicolon? No period?
No. It's going to be semicolon, comma 1. All rows of column 1. Semicolon represent all. If you put it in place of the row index, it means all rows. If you put it in place of the column index, it means all columns. So the colon, sorry, not semicolon, colon, comma 1 means all rows of the first column. Likewise, all rows of the second column and all rows of the third column. So that's how you extract one complete row or one complete column from a matrix. Again, we discussed that last week. It's given in the tutorial as well. That's how to extract rows and columns. I'm just going to write down, since input is scalar, I'm going to write down 1, 2, and 3. So this is the input. This is how you take input of numbers and input of characters, strings. That's how you do it. Now the output. All right. One way to give output, of course, as you saw, is not to put any semicolon after the equation, and it's going to produce the output of that equation. That's very simple. But what if you have to embed the output in a message? Or even if you don't have to embed the output of a message, especially, let me discuss that in a little bit. Let's say you want to give a message such that you want to write down the values of X, Y, and Z that were entered, the equation that was evaluated, and the result of the equation that you got. You want to write down all those things in a message. How are you going to write that down? To print a message and embed values, the command is, or the function is printf or fprintf. I believe in the tutorial I'm using fprintf, so I'm just going to write fprintf here. But printf works the same way. fprintf. All right, and I'm going to embed the characters as well. For example, my name. All right, so %s. You entered x equals, and I'm going to come back and explain everything. You entered x equal %f, y equal %f, and z equal %f to evaluate f, x, y, z equals whatever the equation is. Let me just copy this equation. Equal this equation, and the result is %f. And then here I'm going to write down, and again I'm going to explain everything in this, what I'm writing. I'm going to write down name, comma x, comma y, comma z, comma f. All right. So let me go and move my cursor down so you can see the equation clearly, the syntax clearly. All right, so observe the syntax, what I wrote. Printf, as I said, fprintf or printf, both work. Fprintf, since I'm using fprintf, I'm assuming in my tutorial, so I'm going to stick with the function fprintf. But printf is the same thing. Fprintf actually is for the file printing, but it works as well. So anything that is written in quotes, any character or any message that is written in code is going to be printed as it is. Anything that is written after the percentage sign, followed by a specific data type, S, F, D, whatever. That's where the values will be embedded, that those values you are representing after you complete the message and put a comma. And then these variables that you're putting over here, the values from these variables are going to be replaced wherever it will see the percent sign. So the first percent is going to be replaced by the name. The second %f is going to be replaced by X. Likewise, third and fourth % will be replaced by Y and Z. And the last % is replaced by F. So wherever you see percent, those are called specifiers. And those specifiers are used to replace the values that you want to embed in the message. And each specifier has a different function. S, of course, a string. It represents a string, so it will replace that specifier by a string. F is the floating point, so it's going to replace those values using a floating point or decimal number. Likewise, %d is decimal, integer in general. Then decimal e, %e is exponential value. So those specifiers, I believe, they are given here. Right here. So these specifiers are given here. %f, %d, %e, %g, %s. Okay, so what I'm writing here, I'm writing that %s. First %s, you go to the first variable name. The name, which is a string, is going to be replaced by %s. And then it's going to continue with the message. You entered x is equal to %f. Then it's going to go to the second variable, which is x, is going to replace the value of x right here. Y is equal to %f again, so it's going to go to the third variable. And then z is equal to %f again, so it's going to go to the fourth variable, which is z, to evaluate this expression, and the result is %f. So last %f is going to be replaced by the value of f. So let's go ahead and run this thing. Let me go ahead and do this. CLC and clear. So let's go ahead and run this thing. Enter the value of variables x, y, and should be values. Enter the values of the variables x, y, and z, scalar values, as a vector to evaluate it. So let's say 1.34 as a vector. I'm going to put a square bracket. 1.34, 8.76, 2.36. Enter your name. Masood. So the printf statement, observe, it gives you this output. Masood, you entered x is equal to 1.34000 because it's a short format, f %f. Y is equal to 8.000, and z is equal to, oh, I put 8.76. So it's only taking the first three values, ignoring the last value, 2.36. And z is equal to 76 to evaluate fxyz, which is the equation, and the result is 53.6125. Let me do it again. 1.5, 6.7, 8.92. Enter your name. 1.5, 6.7, 8.92 to evaluate fx is equal to this, and the result is 9.06327. This is fprintf or printf. You can use printf as well. Let me go and do the printf only instead of fprintf. Printf. Same thing. 4, 5.6, 8.8. Name A. A, you entered x is equal to 4, y is equal to 5.6, z is equal to this, to evaluate this equation, and the result is 3.887370. So you can use printf instead of fprintf, or you can use fprintf. So these are specifiers. Now, if you use just %f, as you can see, just %f is going to print out any number that you're entering in the short format. What if you want to truncate it? And also observe that it is putting the command prompt right after the message. What if you want to take the command prompt on the next line? How are you going to do that? To do that, to first of all truncate your number that is displayed. Now remember, truncation of the number does not mean that the value that is calculated is in that precision. The value is still calculated as the complete precision. It's just the display is not going to be all 15 digits or something. So to truncate it, let's say you want only 2 decimal places. Then all you have to do is do 0.2%, 0.2f, which will only display 2 decimal places for that number. And if you want to put a tab in the message, or if you want to go to the next line, you can use \t for tab and \n for new line. So if I put \n over here, and actually I can also put \n at the start. So it's going to skip a line when the message is going to be printed, and also is going to go to the next line when the message is going to end. So \n and \t. \t produces tab. Anywhere you put \t in the message, it's going to produce a tab. And if you put \n, it's going to go to the next line. Let's run it. 1.2, let's extend this a little bit. 1.2, 3.4, 5.67. 3.4, oh. 1.2, 3.4, 5.67. Enter your name, so you entered x is equal to 1.20. First of all, observe it truncated the decimal places to 2 only. Y is equal to 3.40, z is equal to 5.67 to evaluate that. And the result is 6.27, and then it went to the next line. And it also skipped a line before this message was printed because I put \n at the beginning of the sentences, at the beginning of the message as well. So \n anywhere you're going to put inside the quotes in the fprintf command or printf command. At that, wherever you put it, it's gonna skip a line and go to the next line. You can put it anywhere in the message. So that's the fprintf statement.
Professor,
Yes.
since this is so similar to C++, would ending in like, semicolon and then end L semicolon, would that do the same thing?
Yeah, for the formatting of C++, even in Python, you will find pretty much similar syntax. Some stuff is a little different here and there, but many things are the same. Now, what you're saying, ending in semicolon?
It's like semicolon and then end L semicolon. So it's just another way to end the line, basically, is all it is.
Oh, try it. I don't know. But again, if you're trying it in Octave, it's possible it will just execute the C++ code instead of MATLAB code. I know in MATLAB, basically, if you want to go to the next line, you just use \n.
Okay.
That's all it is. Yeah.
Yeah. Right.
Yeah. The problem with Octave is, as you saw that I showed it to you, that it can execute it can compile codes from C, C++, Java, and all those. So sometimes, even if you mix 2 different languages, it will still execute it. Although that might not get executed when you use actually the same code in MATLAB. So I'll just stick with the formatting of whatever the syntax of MATLAB is.
Yeah.
But yeah, you can find pretty much the same thing in Python as well.
Okay.
Some small syntax, there are small differences in syntax, but majority of it is pretty similar. What else? Display. Another function is a display function, DISP. And display function does the same thing that, let's say you want to display the value of f, then it's going to display the value of f. And it's not going to print the variable, but it's just going to display the value. 1.2, 3.4, 5.68. So first, this is the fprintf statement, and the last 6.3602 is displayed using the display function. So it's just display function just displays whatever is written in the parentheses after display function. If it is a message, it's going to display that message inside the quotes. If it's just a variable, it's going to display the value of that variable, but it does not display what variable that you are showing the value for. For example, if you don't put any semicolon, then it's going to display f is equal to this value. But if you use the display function, it's not going to write down what variable is that for which the value is displayed. This comes handy if you are trying to print the result for a matrix operation or vector operation, because fprintf statement does not print vector or matrices properly, because each value of the vector or each value of the matrix requires you to put a separate specifier. So generally, it is not recommended to use fprintf or printf to show matrix result or vector results. In that case, if you want to display the values, then you can do the printf and only send the message that the result of the equation, fx, y, z is, and then after that line you just put display and f. So it's going to write that sentence, write that statement, and then it's going to display the matrix or a variable using the display function. So that looks like you are basically displaying the proper values without adding the variable name f or y or z in the value at the beginning of the value. So fprintf function or printf function is good for scalar values and stuff. You can print vector values as well. However, there are two ways to do that. Of course, first is that you put a specifier for each value of the vector. If you know it's a 2x2 vector, then you put a specifier for each value and the proper formatting. The second way to do it is you convert the vector into a string and just print the string out. So instead of the value to be a vector, you convert that vector into a string. And the function to convert anything into a string is num to a string. Let's see. Num to str. Number to string. 34. So now A is 34, but 34 is not a number. 34 is a set of characters. So if I do, let's say, length of A, then it's going to show me the length of A is 2, of course, because there are 2 characters of A. So now A is a character. So now if you convert characters, then you can use %f in fprintf to print out the value of A. So let's see if we can convert a matrix. B is equal to num to a string. I don't know if we can do that or not, but let's try. 1, 3, 4, 5, 7, 8. I don't know if it will do that, but let's see. Okay, it seems like it will do that. Size of B, 2 rows. Okay, total 7 characters is same. And now if I want to print that out as %s, let's say fprintf, and I do %s, b is equal to %s, and let's say I do b is strings of b. Yeah, it's not doing it. It's not doing it clearly, as you can see. Even if I'm printing it as a string, it is combining the columns 1, 5, 3, 7, and 4, 8. So it's the fprintf or printf, it does not really work well for matrices or vectors unless you define a separate specifier for each value. Then it's possible that you can show it as a vector or a matrix. But if you want to display again vector or a matrix, then don't use printf. Use the display function, display f. And when you do that, then in here you can only write, let's say, Masood, you entered. You evaluated this, and the result is. So I'm not going to put any result over here or XYZ value over here. What I'm going to do, I'm just going to use display F. So let's say if let's say if XYZ are vectors. And for that, of course, I need to go and change that, because I need to have, let me do this, 1, colon, 2, colon, and 3, colon. So I'm gonna enter it as a matrix and then extract each row of that. So let's go ahead and do that. So let's say my X is a vector 1, 2, my Y is 4, 5, and my Z is 8, 9. So I'm going to enter as a matrix. First row is X, second row is Y, and third row is Z. So you evaluated X, Y, Z, 3X, blah, 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 and the result is 7.6 versus 4.3, 8.10. So if your input is a vector, it's better to just use the display. And you can write the message either using printf statement if you have to embed any string or number or character, or you can just simply use display, DISP, and then write the message in quotes. In this case, I'm using printf because I'm embedding the user's name, whatever the name of the user is. So that's why I'm using printf statement. So this is the best way to display, embed the message and the values if you are displaying matrix values or vector values. To write down the message in the printf statement or display statement if you're not embedding anything, and then print out the values using the display function. But if you have a scalar values, then yeah, you can just embed everything using the fprintf or printf function. So that's the printf output functions that we are discussing, display, printf. Examples. We're going to go back to exercises. Actually, let's discuss exercises and then take a break, because the next topic is plotting. And then after the break, we can discuss plot. So let's discuss exercises that you have to do. And the exercises that you have to do are 7, 8, 9, 10, 11. I think 10, 11, 12 for plotting. So 7, 8, 9, let's discuss 7, 8, 9. 5, we don't have to do 6, 7. Okay, 7 exercises. You have to write a program to solve system of linear equations. I showed you how we're going to solve system of linear equations. Exercise 5 is also based upon the system of linear equations. And I showed you at the beginning of today's meeting how you're going to do that in MATLAB. What you're doing in this exercise is you're asking the user to enter the coefficient matrix A. So like I entered the coefficient matrix A. And then you're going to ask the user to enter the constant vector on the right-hand side, C, as a column vector or a row vector, whichever way you want the user to enter. But remember, when you are doing the inversion of matrix, x is equal to A inverse C, then of course C has to be a column vector, and A is, a square matrix basically. And the number of rows of A and number of column of A is going to be the same as the number of unknown variables that you're looking for. So in this exercise, basically it's an exercise to practice for the input command. So you're going to ask the user to enter the coefficient matrix A. If the user is, solving for the unknown variables using matrix inversion method, then enter the coefficient matrix A from the linear equations, and then enter the constant vector C on the right-hand side from the linear equation. And then you're going to perform A inverse C and display the result. That's all you have to do in this exercise. And in this case, you don't have to use display function. You can just remove the semicolon and it's going to show the result. Or if you want, you can use the display function, whatever you want. Exercise 8. You have to ask the user to enter values of some resistors as a vector. So you're going to ask user to enter values of some resistors connected, and those resistors can be either connected in series back to back, such that the same current will be flowing through each one of them. And they can be as many resistors as the user want to enter, or they can be connected in parallel. That is connected between the two same nodes, such that the voltage across them will be the same. And again, they can be as many resistors as the user want to enter. And that's why I'm showing you R1 all the way up to Rn. N can be any number. And then you are going to calculate the equivalent resistance if they are connected in series, all of them. And that simply is the sum of all the resistors. When they're connected in series, the sum of all the resistors is the equivalent resistance. So you can remove all of them and just insert one resistor, which is the sum of all resistors in the circuit. And if they're connected in parallel topology, and if you want to replace all of them that are connected in parallel, and remember, when they're connected in parallel, basically they're connected between the same node. So let's say this is node A and this is node B. All of them will be connected between node A and B, and this is just wire. You're extending the wire. That means it's the same node. And if the resistance are connected in parallel, then the formula to calculate the equivalent resistance to replace all of them is this formula, 1 divided by 1 over R1 plus 1 over R2 plus 1 over R3, all the way up to 1 over R. So user is going to enter the resistor values as a vector. And then based on whatever number of resistor user is going to enter, you're going to calculate the series sum, and you're going to calculate the parallel equivalent. And once that is done, then you are going to use the printf statement, and you're going to put down this statement. If all the resistors are connected in series, equivalent resistance will be X. This X has to be replaced by a value that you get after you calculate the series equivalent. So this X has to be replaced by, or the value must be embedded here, R series, whatever the series equivalent is. That value must be embedded here. And if all the resistors are connected in parallel, equivalent resistance will be Y, which is R parallel. So those two values must be embedded in this message, basically. So you're doing a few things here. First of all, you're using the input command to ask the user to give you the input vector that contain all the resistor values. Then you're going to calculate the series and parallel equivalent. And finally, you're going to use the fprintf statement or printf statement, and you're going to put down this statement and embed the value of R series and R parallel where X and Y is. Make sure you embed it, because I see some students just say X is equal to this, Y is equal to this, and they just write down this statement as it is, and they write down where X is the series equivalent and Y is the parallel equivalent. So no, you have to embed these values, remember. X has to be replaced by this value, R series, and Y has to be replaced by this value. All right, now how are you going to do the series? It's a vector. How you can add all the values in a vector? What is the function? Anybody remember the function?
The sum.
Sum function, exactly. So sum function can add right here. Standard means sum. So sum function can add all the values of a vector. And if you apply sum function on a matrix, it adds all the values of each column and produce a vector. Each column of the vector is the sum of individual columns. So sum function produces the sum value. Product function produces the product value of a vector. Okay, who is going to tell me how you're going to implement the parallel function? How are you going to implement this?
So that's where I got stuck. So
Right. Look at it and then think what you have to do first. You have the vector that has R values, right? You have vector with R1, R2, R3, all the way up to Rn. What you have to do first when you are implementing the parallel? Look at the formula and tell me if you are implementing this formula in your calculator, what you're going to do first.
You're gonna do the divide, just one
You're
divide.
going to do the division, exactly. So how you can do the division of that vector that has all the resistance values, such that each individual value has to be divided?
Could we do the inverse of it?
No, you cannot use inverse function.
Okay.
trust me, I tried that.
Would you just do 1 divided by the inverse of the vector?
Not one divided by n, but before, remember, you told me that first you're going to do 1 over R1, 1 over R2.
Mhm.
How are you going to do that in MATLAB? If you have a vector with R1, R2 values, how are you going to do that? So let's say if I ask you that user is giving you this, and I ask you R equivalent, calculate 3 over R. How are you going to calculate 3 over R? What you going to write?
Just 3 divided by R?
No, R is a vector, remember? R is a vector, right? So you cannot just do 3 divided by R. There's something else you have to do.
Oh, the period R.
Period, 3 period division, sign, and R. So how you can perform this? 1 over R1, 1 over R2, 1 over R3, all those things.
So would it be like, no, go ahead, you can go.
Because remember, you are adding what? You're adding 1 over R1, 1 over R2, 1 over R3, all those. That means you need to have first what? You need to have first 1 over R1, 1 over R2, 1 over R3, all the way up to 1 over Rn before you perform the addition. So how are you going to do that?
So just 1 divided by, no, wait, no, 1 period divide.
There you go.
Your vector.
Exactly. Simply 1 period division sign R. That's going to produce the reciprocal of each value and give you another vector where each value is assigned. So once you have that vector where the reciprocal of each value is present, what is the next step?
You could use a sum.
Exactly. You're adding all of those. All those values you're adding. So you're summing up all those values like you did for series. And then what is the third step?
Do 1 divided by the sum?
1 divided by sum, exactly. So this, to calculate the parallel, there are 3 steps. First, you are taking the reciprocal of each value of the vector. Then you're adding all of those values, all of the reciprocal values, and then you are basically you're taking the reciprocal of the sum that you get in step number 2. It's very easy. If you look at, again, if you look at it, it's very easy. Now, the same thing can be done using for loops that we're going to discuss, and we discuss for loops in LabVIEW. The same thing can be used with for loop, but it's going to be more complicated than just by using the sum function in MATLAB. It's much easier to use the sum function in MATLAB to perform this operation than using the for loop. So this is how you're going to do this exercise. Very simple exercise. And remember, use printf function to embed these values and input function to get user to enter these values. And again, user can enter as many values as the user want. You cannot restrict the user to just enter 4 values, 5 values, 3 values. And just tell user to enter a vector with register values that you want to find the equivalent, series equivalent, and parallel equivalent. As simple as that. So that's exercise 8. Exercise 9. Include fprintf in exercise 6 to print the roots of the quadratic equations with the following message. Roots of the quadratic equation ax squared plus bx plus c is equal to 0. Root number 1 and root number 2. Okay, what is exercise 6? Exercise 6 is basically asking you to calculate the roots of a quadratic equation. So you're asking user to enter a, b, and c, the coefficient of the quadratic equation, and then you're applying the quadratic formula to calculate the roots of the quadratic equation. 2 roots, both can be real or both can be complex conjugate. So exercise 6 extension is exercise 9. That's why I just asked you to do exercise 9, because when you're doing exercise 9, exercise 6 is done already. In exercise 9, you're going to be doing the same thing. You're going to ask the user to enter the coefficients of the quadratic equation. Now, I want you to ask the user to enter the coefficient as a vector. Ask the user to enter a, b, and c as a vector. So don't ask to enter them separately. Enter A, enter B, enter C. Don't do that. Ask them enter the coefficients of the quadratic equation A, B, and C as a vector. So I'm going to enter, let's say 1, 2, 3 in square brackets. And then in your program, you can extract the first value as A, the second value as B, and the third value as C, as I showed you in one of the exercises. And once you do that, then you apply the quadratic formula. You calculate 2 roots, root number 1 using the quadratic formula and root number 2 using the quadratic formula. And once you have all this information available, then you are going to write down using fprintf, you're going to write down this message, roots of the quadratic equation, ax squared plus bx plus c. Now, a, b, and c values, you need to embed the values that user has entered. A, b, and c, you're going to, if I put 1, 2, and 3, you're going to put 1x squared plus 2x plus c plus 3 is equal to 0 are root number 1 and root number 2. So you're gonna embed the values of both the roots. So observe, enter the coefficient of the quadratic. This is just a sample. I ran my program. 1, 5, and 10. Roots of the quadratic equation 1x squared plus 5x plus 10. It's better if there is 1, don't put 1x squared, just put x squared. But even if you're putting 1x squared, that is fine, because we have not yet worked with if-else loop. But if you have if, then you can put a condition. If a is 1, then don't put anything here. But in this case, that's fine. So I embed these values a, b, and c, and then I put my 2 calculated roots. And in this case, my roots were complex, so they're complex conjugate of each other. A word of caution. You cannot print the complex conjugate numbers, or complex numbers, using a single specifier. Either you use 2 specifiers, one for the real part, one for the imaginary part. Or easier way is to convert the complex number into a string using num2string function that I showed you, and then just print it as a string in the message. It's your choice, whichever way you want to do it. But make sure that both the roots are printed properly. whether you're taking the real part and imaginary part separately and printing them separately with a J in between, or you are converting them into a string and printing them as characters instead of numbers. So it's your call, whichever way you want to do it. But make sure that they're printed properly, especially if they are complex numbers. So these are exercises before plot that you have to do. Let's go ahead and take